Welcome to the first instructional video on using the Numeris Model Builder Data and Simulation Analysis web app. I am Wayne Getz and will be your instructor for this session. It will cover topics of how to prepare and load incidence and mortality data, how to change default parameter values that are already part of the web app, and how to save data and parameter values. But first, I would like to say something about the epidemiological model that underpins the web app simulation engine. You may be familiar with the SEIR framework for modeling infectious disease outbreaks and epidemics. SEIR is an acronym for the disease state that individuals can be in when considered part of the epidemic process. S represents susceptible, E, exposed, meaning individuals that have come into contact with the pathogen and are currently in the latent phase of infection. I, individuals in the infectious stage, and R is individuals in the removed phase. The removed phase can either consist of an immune phase, where V means natural vaccination, or they could have died from the disease. An extended version of the SEIR framework is the SCLAVE framework, in which individuals in the exposed class E are now explicitly divided into a contact class C, in which individuals having contacted the pathogen can either succumb to infection by moving on to the latent class L, or thwart the infection by moving back to the susceptible class S. Individuals in L then move after a period of time called the latent period to becoming infectious but still asymptomatic, that is, in class A. These asymptomatic individuals may then recover to the immune class V, or go on to become more infectious as part of the infectious class I. Individuals in I, after a period that corresponds to the recovery time, may then move on to the immune class V, or a small proportion may die at a disease-induced mortality rate and move into class D. Individuals in the immune class V may ultimately lose their immunity and cycle back into S, but this only happens after many months or even years, and so does not play an important part in the initial outbreak phase. However, the cycling back becomes important when looking at issues relating to the persistence of the disease over time or its reoccurrence every few years. Paralleling the SCLAVE sequence is the SCLAVE response sequence, where individuals transfer due to social distancing, behavioral responses, and healthcare measures to a shelter-in-place class SR, while individuals in C, L, and A that have been identified through contact tracing as having made contact with the pathogen are transferred to CR, LR, and AR through implementation of quarantine measures. Individuals in I, having been diagnosed with the disease because they're symptomatic, are transferred to class IR, where they are treated and likely isolated, while we also allow for the possibility that individuals in S are vaccinated and transferred to a class VR once a vaccine has been developed and a vaccination process is rolled out. We now return to the website itself to discuss issues of data entry and the setting of parameters. So let's click to enter the website and go to the first page, which is the parameter page. You'll see on the parameter page that we have a number of different windows. This window over here is where we can enter the incidence and mortality data. So let's talk a little bit about that before discussing the other parameters. A number of websites exists. Here's one, which is the worldometer.info website. And we're looking at the coronavirus country page where Israel data has been depicted. And if we look at this particular website, we'll see that there are a number of plots. Here's total coronavirus cases. Here are the daily new cases in Israel, and you can either have the raw data, which you see is quite variable and therefore not very reliably reported every day. So some days it's not reported fully, and other days you get reports from previous days included. So one works rather with the 7-day moving average rather than the data itself. You can also look at plots of active cases, mortality. Here's the mortality rate going up over time. Here are the new daily deaths. So this is the kind of data that one can use. And in particular, we're interested in daily new cases or incidents, and we're interested in the 7-day average of this. And we're also interested in looking at the mortality data. Mortality and incidence data can be obtained from the website in different forms. Once the data have been obtained, what we're interested in is what we call the incidence time series and the mortality time series. And we arrange the numbers in 2 rows, the first being incidence, the second being mortality. And this particular file, which I've called Israel data, is a CSV file or a comma separated values file. And this is the type of file that the website uses to read in the data that's going to be fitted to the model. So returning back to the website, you'll see here that we can choose a file. Let's choose the file. And this will take us to the file that I just showed you, which can then be read in. And once it's read in, the values will be seen here rather as 2 columns than 2 rows. And the time is set so that the first data point is called time 0, and the last data point is automatically recorded as time 136. Because it starts at time 0, we have 137 data points. We have other timing values. For example, we may only want to fit the model to the first 30 points rather than all 137 points. We may also want to simulate the model. We can simulate the model, for example, 100 time steps. Or if we simulate the model beyond the data string size, then this will be called a forecast and will project what's going to happen to the population into the future by creating values that we don't yet have. Over here, we see that we have a set of epidemic parameters like contact rates, infection rate reduction. So this is what happens or the value we give to the relative infectiousness of the asymptomatics compared to the symptomatics. We have the succumb period, which is the rate at which individuals in class C will move over to class L, or the thwart period, which determines the rate at which individuals in class C go back to S. We have a latent period, which is the rate at which individuals in class L go to class A. We have a rate at which individuals in class A go to class I, and so on. We also need to start off the outbreak with some initial values. So when the first case is observed, That means there are many more individuals that have already been exposed. And just because we see the first case doesn't necessarily mean it's the actual real first case. There may be several cases that have not yet been detected. There are also other parameters relating to the epidemic drivers like social distancing rates, social relaxation rates, and quarantining and so on that we'll talk about later. What we have here is a default setting. So for example, if we clear the settings and we press default settings, a default set comes up. If we want to load settings that we've saved, then we can press load settings, and this will take us to, this will give us the option to choose a file that we've already saved before. And if we've got a set of settings that we want to save, we can press save settings. We can also take these values. You see the preferred values are the values that are actually used. The min and max are just to give a plausible range and also to give some idea of the range of values that should be looked at when we undertake an optimization. So this then is the information that you need in order to get started on being able to use the website to carry out some simulations and parameter estimation procedures. These will be discussed in the next videos in this series. So thank you very much for listening, and we hope that you're ready to move on to the next phase and to use a set of data to start fitting the model to these data and then analyzing the outbreak and trying to understand it in terms of the parameters that are identified in the model fitting process.